Hello, welcome to this video that's going to go through the integers and rational numbers worksheet answers. So for the first question, for the following numbers below, determine whether they are an integer. So 45 is an integer, it's a whole number. So say that this one is an integer. 0 is, if we remember, is an example of an integer. We went through that in the class. It is, if you think about it, minus 2, minus 1, 0, 1. 2, so we treat it as an integer. Minus 342 is also an example of an integer, even it's a negative number, and they are quite happy to be integers as long as they have no decimal points. And talking about decimal points, we have an example here. 45.1 is not an integer. So this one is not an integer, and therefore we cannot say, as it's got a decimal place. We have 76 divided by 3. If you plug this into your calculator, you should have 25.333 recurring. This is not an integer as well because the result is a decimal. We have the next one, which is 12 over 2. Well, 12 over 2 is equal to 6, which therefore means that it is an integer. And finally, we have minus 18 over 3. This one is minus 6. Which is an integer as well. So be careful when you see a fraction. A fraction might not look like an integer, but when you get the result, it will, if it results in an integer, we can take that forward as an integer value. For the following numbers, determine if they are rational or an irrational number. So here, a rational number, if we remember, is something that can be written as a fraction. So 13 can be written as 13 over 1. And therefore is a rational number. Minus 9, exactly the same, minus 9 over 1, so therefore rational. 3 over 5 is perfectly fine. Remember, the definition for rational is written as a fraction, so we'll write that there to remind us. So we can say that this is a rational number. Minus 4 over 9 is also a rational number. Minus 0.625 is a perfectly rational number. It is actually 5 over 8 as a fraction, but you didn't need to know that. You just need to remember that a rational number as well is also a recurring decimal, or what we call a terminating decimal, which means that it stops at a particular value. Root 8 is what we call an irrational number, because the square root of 8 is equal to something like a very long digit, which therefore means that it is irrational. The result does not equal an integer. Root 4 is equal to 2, so therefore it's a rational number. 3 pi, now pi is not a rational number. Oops, not number. So therefore 3 pi is also not rational or irrational. Because if you have pi, if you have a rational number and you multiply it, but even if you multiply it by a rational number, that still will continue to be an irrational number. So square root of 324, if you did this on your calculator, you should get 18, which means that it is rational. And the final one, minus 0.293133, is actually a rational number, because it's what's called a terminating decimal. It has an end point to its decimal, therefore it can eventually be written as a fraction. Even though the fraction will be very difficult, we can still treat it as a rational number. So if you see an example like this in your exam, it will be a rational number. It's only if it's a non-recurring decimal or an infinite one. So the numbers, if for example the numbers kept going on and on and on and on and on, therefore we can say that this is an irrational number. But in this example, in our question, It doesn't, so therefore we say it's a rational number. If you do have any questions, please let me know. Thank you for listening and have a nice day.